$3,062. Projected to get to 50. So I'm going to turn 3,000 into 5,000 here in a hurry. Okay. Let me know when you guys have a ruler. We'll get started with this today, and I think this will hit, this makes perfect sense today, I think. All right, everybody have a ruler this morning? If you don't have one, make sure you get one. Guys, I want to start by asking some questions from stuff that we've done in the past. I really think that what we're going to look at today is going to make total sense, and I think that we'll buzz right through this. And, I'll get you an assignment on this. You probably have some time in class to get most of it accomplished. But hey, quick question right here. I'm going to go back to some very easy stuff. Solve that for me. What are you going to say? X equals 3. Is 3 my only solution, or are there more solutions than 3? 3 is the only solution, right? What would happen if I did this? If I solve this, the principle would be the same. Divide both sides by what? 2. Divide both sides by 2. But when I get done with this, I get x is greater than 3. Does that mean there's just one solution to that, or are there multiple solutions to that? Why multiple solutions to that? Faith, help me out. So there's many numbers that are bigger than 3, right? So there's going to be multiple solutions today. And that's exactly what we're going to start looking at today. We're going to look at, in a coordinate plane, when we deal with two variables, what's the effect of changing an equal sign into some sort of an inequality sign? And I want to show you what that looks like in a coordinate plane. So if you'll do this for me today, guys, look at your notes. 5.6 is titled Graphing Inequalities in Two Variables. The examples that I showed you right here, how many variables were we talking about? 1. So I want to start looking at this in two-variable form today. We want to ask ourselves, how do you graph an inequality in two variables? A lot of it's going to be in the coordinate plane. And we've been graphing a lot of lines in the coordinate plane lately. So I think that this is going to make total sense when we do this. We'll get through our goals. We'll get through the vocab. A couple of recall plans I want to make sure that we have in place. And I'll show you how to handle this stuff. So here we go. Guys, our goals for the day, we want to be able to check solutions of linear inequalities. We want to be able to graph linear inequalities in two variables, and then use those graphs to represent a real-life situation. So, that being said, let's kind of get ourselves familiar with the vocab right here. I need a volunteer to read my definition of this first one right up here, linear inequality in two variables. How about a volunteer to read that? Go ahead, Maddie.
A linear inequality in two variables, x and y, can be written as ax plus by is greater than is less than c. Ax plus by is less than or equal to c. Ax plus by is greater than c, and ax plus by is greater than or equal to c, where a, b, and c are real numbers.
A lot of wordiness to that, right? In a nutshell, what that means is this. We're going to start looking at inequalities that are going to be of two variables. You might have something as an example like 3x plus 2y, maybe less than or equal to, say, 4 right here. Now, they use a, b, and c are in front of x and y here. Guys, all they're really saying is a, b, and c are some numbers. So, like when I have the ax part up here, what's my a value in this example right here? 3. What's the b value? And how about your c value? That's all it's really saying. So this would be an example of an inequality of how many variables? Specifically, which two variables? X and y. Okay. We're going to talk about what a solution of a linear inequality looks like. It's going to be an ordered pair x comma y. It's going to be an ordered pair x comma y that makes my inequality true. So as an example here, guys, if I pick the point 0, 0 to see if that's a solution up here, help me plug in 0 for x and 0 for y. If I plug in 0 for x and 0 for y on the left side, what's my value on the left when I plug zeros in on the left side? 0. Is 0 less than or equal to 4? Does 0, 0 make that inequality true then? So 0, 0 would be one of the solutions of many for that inequality. All right? Graph of a linear inequality in two variables is going to show all the solutions of the inequality in the coordinate plane. I'll show you what that looks like. Guys, this last one, half planes. It says the boundary line divides the coordinate plane into two half planes. A lot of our graphs today are going to look like this. You're going to have a coordinate plane. You're going to have a graph of a line. Might be a solid line, might be a dotted line. I'll show you the difference here in a second. And then what we do is we end up shading one side because those are the points that would represent true values for the inequality. So that one line takes that coordinate plane and divides it into a plane that's shaded and a plane that is not shaded. So half planes, it just means you're either on one side of the line, that's half the plane, the other side of the line would be the other half of the plane. Okay? It's not like an airplane with one wing. That'd be scary. Half a plane. I don't like full planes. I get on. Scared. Oh, I'm scared to fly. I hate it. I do not like to fly. Good morning, Maggie. How are you today? All right. So those are all the vocab terms we're going to be discussing as we progress through this section right here. I want to go back and recall some forms and what I think is important of the forms of the lines to be able to do what we're going to do today. So what I'm going to ask you guys to do is this. First thing I'm going to ask you to recall is slope-intercept form. We should be able to spit that out easily. What is general form of slope-intercept form? Okay, I'm going to write this down. Y equals mx plus b. Very good. All right, so what kinds of information can I get out of that general form again? Remind me. Remind me what I get out of that general form. What's m represent, in other words? Okay, so m is the slope again. We're going to need to know that at times. And now what's b represent? The y-intercept. Very good. So I'm going to fill those in there. All right. Now the one that we're going to probably use most often in this section today is going to be an inequality that involves standard form. Right? Standard form, I'm going to write down here, this is the one you're going to use most often here. Standard form takes on the form ax plus by equals c. All right, ax plus by equals c. So in this middle box right here, I'm going to tell you to do this. Write down that we want to know what the slope is. Okay? How do you find the slope of an equation in standard form? All right, here's how you do this. That formula that's important to us will be the opposite of a over b in that middle box. Opposite of a over b. And then just like in slope-intercept form, it would be really nice if I knew where to start. Where's the y-intercept at? Okay. Anybody recall the formula for the y-intercept of slope-intercept form? We've done it this year. Something over something. I'll remind you that. Not a over b. C divided by b. Yep, c divided by b. So I'm going to write down, we're also going to want to know the y-intercept from stuff in standard form. That's found by taking your c value, dividing it by your b value. Okay, so make sure you have those down. All right, guys, horizontal form. Horizontal form, like this. Left to right, right? Okay, this would be what kind of a line? Vertical. This would be... Whoa. Way better than if there was... It's horizontal, right? Okay, horizontal and vertical. Holy cow.
Thank you.
Drop your weapon and slowly walk away. All right? Okay, horizontal form. Horizontal form, I'm going to take on this. Y equals some number is what you're going to have here. All right? Y equals some number. You might have like y equals 4, or y equals 10, or y equals 20. Bottom line is what variable doesn't exist here? There's no x in this, so horizontal form. Okay, so here's what I'm going to write down here. I'm going to write this down here. You want to start at, I'll use the at symbol, the number that you're dealing with. So if there's like a 5 in here, you're going to start at the number on the y-axis. All right, so if this was like y is less than 5, on the y-axis I would go up to what value? Well, run up to 5, and I'll show you what that looks like here in a second. And then you're going to draw a line that runs left to right. Line that runs left to right. Okay. Again, just a lot of general rules right now before we get into this, so make sure you have those down. All right, anybody need more time with the first page? Everybody have what you need right there? All good? All right, last one that we want to recall, then we'll start looking at examples, and this is pretty slick here, guys. Vertical form. Guys, if horizontal form was y equals some number, what's your expectation for vertical form then? X equals some number, all right? And we've done this before. So again, we just want to make sure we're refreshing ourselves on this and understand how to do this. So you're going to start at whatever the number is on the x-axis. Okay, you're going to start at the number on the x-axis, and then you're going to draw a line that's up and down. Draw a line that's up and down. Okay, let's get into the heart of the matter today. The one thing I want to familiarize you with here today first before we start getting into this is that in checking solutions, again, I want you to be able to use Desmos as a tool to help you confirm answers. Not to get answers so much, but to help you confirm what you're doing. So right here, we're going to do part A quickly. I'm going to show you how to substitute stuff in part A, but you might want to have Desmos open for this, so I'm going to do that here quickly. How have you guys' computers been doing lately? I seem to be very slow lately. Okay. Well, if you don't get to it today, I'll have it up here for sure. But, all right, guys, here we go. At the very beginning of the vocab, we talked about this idea for checking solutions. We said a solution to any inequality would be a point that makes the inequality true. Okay? And in this first example right here, example A, they ask us, hey, suppose you have an inequality 3x minus y less than 2. I want to know, is negative 2 comma 2 a solution? Okay? So here's what I'm going to do, guys. Basically, we're going to take this negative 2 and substitute it for x, and this y value, well, we're going to put a 2 in there. So help me do this, guys. This will become 3 times what value? Negative 2 minus my y value, which is 2, and we're going to say less than 2. Now on the left side we have a mess here, but we've got values there, so we should be able to figure out what that is. So help me out here, guys. 3 times negative 2 is negative 6 minus 2 more would be negative 8. So I have negative 8 less than 2. All right. So guys, when I substitute my point in, negative 2 comma 2 in this case, you have a comparison that says negative 8 is less than 2. How about that statement? That's true. So what do you think here, guys? It says, tell her that point is a solution now. What do you think? Since that's true, what do you want to say here? You're saying what again, Mason? So you're going to say negative 2 comma 2 is a solution because what kind of a statement did we get? Good. True one, right? This is true right here. Yep. This is true. So right here, guys, this is what I'll say. I'll say negative 2 comma 2 is a solution because, because it makes a true statement. Negative 2 comma 2 is a solution because it makes a true statement. How about it makes a true statement right here? All right, negative 2 comma 2 is a solution because it makes a true statement. What I'd ask you guys to do right now, try B on your own. See what you get there. Try B on your own. I want to know if 1 comma 3 is a solution to the inequality they give you up there. So go ahead and grind that out there. See what you get. What are you guys finding out here on B? Solution or no solution? Not a solution? Okay, not a solution. Let's check it. You guys agree that I'm substituting correctly? 4 times 1 minus 3 greater than or equal to 5? All right, so what's the left turn out to be when you do this? So my statement, 1 greater than or equal to 5. How about that statement? True or not true? It's false, isn't it? So here I would say 1 comma 3 is not a solution. Okay, 1 comma 3 is not a solution. Now I want to show you something here quickly. I want to jump into decimals here. If you guys could have access to A and B ready for me to kind of show you what solutions look like and what solutions don't look like here, to help us maybe understand example 2 and 3 a little bit better as we finish up here today. So, everybody have down what they need right here? Okay. What I would like someone to do is this. In decimals, I'd like someone to read that first inequality to me. What was that first inequality? Letter A. 3x minus y. All right. Less than? Oops. All right, so right here, when I punch that in there, here's the deal. Your calculator is good enough here to show you what the solution looks like. Again, I want this as a tool for confirmation, not a tool to do the work, but a tool for confirmation right here. All right, what point were we checking in part A? 2 comma what? 2 comma, I'm sorry, negative 2 comma 2, wasn't it? Be right there. That point, negative 2 comma 2, what region does that show up in? The shaded or the unshaded? So that means that any point in this shaded region right here would make this original inequality true. So let me ask you a question. How about negative 6, 0? Solution? How about the point over here, maybe 6 comma 2? Solution? No, not going to be. Okay? Now if you notice right here, guys, your boundary line is actually what kind of a boundary line? Solid or dotted? Dotted. Keep that in mind, all right? Keep that in mind. I want to punch the other one in here, part B. Part B. What's the inequality in part B, please?
4x.
4x minus y less than or equal to? Less than or equal to?
5.
Here's that graph. Greater than or equal to? All right, let me back that up. Greater than or equal to 5? Whoops. Not good, not good, not good. Greater than or equal to, you said, Maddie? All right. All right, what point were we checking to see if it was a solution in part B? Was it 1 comma 3? So right 1 would be here, and up 3 would be right here. Did that point fall in the shaded region or the unshaded region? Unshaded. So if a point falls in the unshaded region, is it a solution or not a solution? Not a solution. If a point falls in the shaded region, solution or not a solution? Okay. Notice what kind of boundary line I have here. solid here, okay? Solid. Let me show you what's going on here. Let's try and practice some of these here quickly. Again, decimals is there to help you confirm stuff. Let's see what we can do on our own without it. I want to make a note right up here, guys. Example 2, graphing linear inequalities. Okay? I'm going to give you some general questions that I think you should ask yourself each time when you do these to help you make sure you got this right every time. But before I do this, I'm going to make a note up here. I'm going to tell you guys, if you ever have a less than or greater than sign, you will always have a dotted boundary line. Here's a question for you. True or false statement there? 3 is greater than 3. How about this statement? 3 is greater than or equal to 3. True. Okay. Guys, over here I'm telling you the following. If you ever have signs with less than or greater than, and they want to know if a point is a solution, if a point ever falls on a dotted line, you would say it's not a solution. Okay? It will not be a solution because this dotted line would be something that would be what type of a statement? False. Now, if anything ever falls on a, what do you think we're going to use for the signs greater than or less than or equal to? Not dotted, but solid. If anything ever falls on a solid line, like this type of a statement, what kind of a statement did you get here? With an equal sign, what kind of statement do I have right here? True. True. If you ever get any point that falls on a solid line, that will be a solution. So a dotted line is like a boundary line that gets you started on a problem, but that line's really not there. Okay? Anything that's dotted is really not there. Anything that's solid is considered true. All right, so let's look at this, guys. How do you graph these without using decimals? Here's the questions I like to ask. We're going to graph this following inequality, y greater than or equal to -3. The first question I'm going to ask you is, well, what form is my boundary line going to be in? All right. So this is where we had that recall stuff at the beginning of the hour. We had 4 different forms: slope-intercept form, standard form, horizontal form, and vertical form. That boundary line for y greater than or equal to -3, what form is that in? Which one? Why horizontal, Kylie? Well, right here, horizontal form, y and some number, right? There's no x's to it, right? Okay. What is that? Pounding. So this form is horizontal form. This line is going to be a horizontal line. So I'm going to jot this down. This is in horizontal form. Okay. Then the second question I like to ask myself is the following. What kind of a boundary line are you going to have? Will your boundary line be solid or dotted here, kiddos? Be solid. The equal sign in the inequality says solid. All right, so to graph this, I'm going to zoom up on this a little bit. To graph this, we're going to go down to, what was it, y greater than or equal to -3, was that right? On the y-axis, I'm going to jump down to -3, right there. And then I'm going to draw a horizontal line through it, and this is where I want you to use your rulers. So go ahead and draw your line horizontally right through their leg. Draw that line like a boss. Ah! Okay. Here's your boundary line. Now, we've already explored this and said, hey, we want all the points that are going to make this true. So we know we have to shade one of the half planes. I have a half plane above the boundary line and a half plane below the boundary line. Guys, the question becomes this: how do you determine which way to shade? And this is what your third step for solving these should be. I like to choose 2 points, just to confirm this. Choose 2 points on each side of the line. When I say each side of the line, I mean don't pick a point on the boundary line. All right, so here's what I'm going to use as my points. I'm going to use 0, 0. Is 0, 0 on the boundary line? No. And then I'm going to choose this one. Maybe, how about 7 comma negative 7? I'm going to use those 2 points right there. I pick a point above the line. I pick a point below the line. And then, guys, this is just like the beginning of the unit. We said, how do you check to see if something's a solution? We'll plug it into your original inequality. So in our original inequality, y greater than or equal to negative 3, the only variable I can plug in for is what? Y. So if I plug this point 0 comma 0 in, help me out, guys. When I pick that point up here, 0 comma 0, top side of the line, if I plug the 0 in for y, this becomes 0 is greater than or equal to negative 3. Statement, a true statement or false statement? 0 is larger than negative 3, isn't it? So true that. This point makes the inequality true. How about if I chose 7 comma negative 7 to plug in? What's the y value I would plug into the inequality? What's the y value you'd plug in? Negative 7. This says negative 7 is greater than or equal to negative 3. How about that statement? False, right? So kids, the question becomes this. In relationship to that boundary line that separates our coordinate plane into 2 half planes, which half plane you want to shade? The upper part, the part where the 1 point made it true. These are going to be the collection of points right up here. This will be the collection of points right up here that makes the inequality true at all times. So any point in the shaded region is going to give you a true statement there. Right? Now, is it necessary to check with 2 points? Not really. If you plug a point in, it's true, go to the side that point is. If it would turn out false, then go to the opposite side, wouldn't you? Well, you got to be careful on this. You want the shortcut on shading?
Yeah.
You guys want the shortcut on shading? Okay, I'll put it up here on the board. It won't show up in notes, but here's the board. If you ever have a y, I don't care if y is this way or what. If you ever have a y in here, and the sign points at this right here. So if you have wherever your y is and wherever your inequality is, if the inequality is pointing at the y, always go below or left, if you will. Okay? If you ever have a y and then the sign is pointing away from it, if you have a y value and the sign is going away from it, then you will always go above or right, however you look at that. So that's kind of the cheater way right there. So here's my question. What if I had something like this? Zero pointing at y, or is it going away from y? It's pointing at y, right? So if it's pointing at y, am I going below or above? Below, right? If it points at y, you go below. That's the rule. Okay? That's the rule if you want. All right. I still like plugging points in to confirm stuff. All right, let's try another one here. Let's try another one here. So I think it's important again to start these out by asking yourself what form you're in. Oh, we don't want that. What form am I in? Check this one out right here. 1x plus 1y less than 2. Which form are we in? I heard it somewhere. Standard form. Okay? Now, if you look at the recall part in your notes, I said, hey, we need to know 2 things in standard form. Before I do those 2 things, I first of all want to know about my boundary line. Tell me about your boundary line. Solid or dotted? You bet. This sign's going to make it dotted. All right, here we go. We need to know the slope. We need to know the y-intercept to get our boundary line. How do you find slope in standard form again? What's that? That would be the intercept. How about slope first? Not quite. Not quite. Look at your notes. We wrote it down already. It's on the front side of your notes in standard form. Opposite of A, which would be -1, over my B value, which is 1. So you guys agree the slope's -1 here? And then, Kylie, back to you. What's the y-intercept? C divided by B. So 2 divided by really 1, which is 2. Okay, no problem. So a y-intercept of 2, that would be right up here. And then how much would slope to that? Be down 1 and over 1, wouldn't it? And now if you're straight ahead, what kind of a line do you want to put there? Dotted, so I'll do the same. Go put a dotted line in there. You guys go ahead and get your dotted line in there. Okay, how have I done there? Pretty good? Guys, I like to pick 0, 0 if I can put it in to substitute to figure out which way to shade. Can I put 0, 0 in this time? Why can I put 0, 0 in? It's not on the boundary line, so let's do that. I'm going to plug 0, 0 in right up here. So when this inequality x plus y is less than 2, I would put 0 in for x, whoops, and 0 in for y. Right, so 0, 0 being right here, below that line. By the way, well, never mind. Is this statement going to be true or false? It's true. I plug this point in, 0, 0, which is below the boundary line, makes it true. So should I shade below there, or should I shade above? Shade below. Okay. Now, how many of you guys looked at this and said, well, the arrow's pointing at y, so we'll go below. That would work as well, right? So here comes my shaded region. These are all the points here that are going to make the inequality true. Did I miss a spot yet? So pretty. Huh?
No, person, you're on the line. Don't act like you.
Do I need to do it over? I'll fix you. Close. That's pretty good, right? Is that pretty good?
Yeah, you're alright. Same. Yeah, I do too.
Oh, okay. Any questions about that, kiddos? You guys are much livelier in the afternoon than you are in the morning. Did you know that?
I'm a tired person. I only have one socket.
All right, let's get this last one knocked out of here, and I'll leave you alone here for the rest of the month. I promise. I won't bother you the rest of the month. Okay. All right, here we go, guys. This is a real life example, and this is where stuff comes into play pretty well. Now, guys, if you notice right here in our example, we've gone from 4 quadrants right down to what? 1 quadrant. Now, in this example right here, we're going to be talking about pounds of food. Okay. Now, why would I go ahead and give you a graph that goes from 4 quadrants down to just the 1 quadrant when we're talking about pounds of food? Because you're not going to have any negative pounds of food. Okay? Okay? I don't know. How would you have negative pounds of food?
Eat it all.
I don't know.
Levi said throwing it up.
Throwing it up. But that still has mass, so wouldn't that
Yeah.
still be positive pounds?
Disappearing it. Nice.
A lot of your real life problems are going to occur in the first quadrant. So what I kind of want you to do is this. Pretend that this part down here and down here, they're not there. The only thing we're in is in the first quadrant, okay? So what we need to do, guys, is this. We need to write a real life example to model this and then show the possible solutions and then pick out some solutions that would say, hey, this is what's going on here, all right? How about I volunteer to read my example here, this last one for the day? Thanks, Sally.
Okay. You can spend at most $9 on potatoes and carrots for stew. Potatoes cost $3 per pound and carrots cost $1.50 per pound. Write a graphic inequality that represents the amount of potatoes and carrots you can buy. Identify and interpret key solutions.
We'll interpret one of them and figure out what's going on here. So I walk into the store with how much money, guys? $9. And we're buying some taters and we're buying some carrots. All right? All right? Tater tots? Okay. I eat carrots every day. All right. Well, anyway, here's the deal. I walk in there with $9. So talk to me about what I'm possibly able to spend. I spend $7. I spend 8. Can I spend 9? I spend 10. So the idea is that I can buy some carrots and potatoes as long as I spend at or less than what? So less than or equal to $9. We all agree? All right. Here's what I'm going to do. I'm going to let this x-axis right here, I'll let the x be the number of pounds of potatoes. So what do you think we're going to let y represent on the y-axis? We'll let y represent the number of pounds of carrots. Okay, so I walk in the store. I notice that potatoes are $3 per pound. How many pounds of potatoes am I getting? X. Okay, so what's an expression for the amount of money you're going to spend on potatoes at $3 per pound for X pounds? 3X, all right? To that, we're going to add in the cost of some carrots. How many pounds of carrots are we buying? How do we set the axis up? How many pounds of carrots are y? At how much per pound? Plus 1.50 y. Now this is the expression for the cost of carrots and potatoes. We want this expression to compare to 9 how? We want this to be less than or equal to 9. All right. So that inequality that we've written right there, that's the model to this problem. That is my model. So here come the questions. What form is that? Standard form, right? What type of boundary line will you have? Solid. So let's do this. How about my slope for this? What over what? Since we're in standard form. -3 over 1.5. That divides out to be -2. That's my slope. Okay? My intercept, my y-intercept, that's going to be c divided by b. So what divided by what? 9 divided by 150. I'll just tell you that 9 divided by 1.5 when you punch it up is 6. Okay? 6. So here's how I want to look at this graphically. We have a starting point at what value? 6. So I'm going to go ahead and plot the y-intercept to 6. And from there, how about your slope? Down 2 over 1. Boom. Down 2 over 1. And then what kind of a line here, kiddos? Solid. Now I'm going to make my line like this because we want to stay in the first quadrant. So I'm going to start up here at the intercept on the y-axis of 6 and follow it down to 3. And it should be solid, right? So there we go. Is that better? Everybody okay with that? All right. Hey, can I plug 0, 0 in here again? Let's plug 0, 0 in. What's 3 times 0 up here? What's 1.5 times 0? Statement true or false? Statement's true, isn't it? So this point 0, 0 makes it a true statement, so am I shading above or below our boundary line within the first quadrant? Gonna shade above it, right? No, we'll shade below it, where 0, 0 is. Okay, so you guys get the idea here. We call this point right here, or this part right here, my region of solutions, okay? What we call this region right here in a real life situation, we call this, and anytime it deals with money, this is what we call a feasible region. It means it's financially possible. Now again, guys, where do all the solutions lie? What area? What part? Where do all the solutions to an inequality lie? Shaded or unshaded? Okay, quick question here, guys. I have a point 1, 2 right here. Is that point in the shaded region or not? This point 1, 2 is in the shaded region. So is it possible to buy, when I call this 1, 2, 1 pound of potatoes and 2 pounds of carrots? Yes. How about this point over here? Is it? Let me ask this question. Could you buy 4 pounds of potatoes? Okay, 4 pounds of potatoes would be all the way to the right here. 4 pounds of potatoes. Am I in the shaded region or not? No. Let me ask this question. Could I buy 2 pounds of potatoes and 2 pounds of carrots? Where is 2, 2 at? It's right on the boundary line. As long as that boundary line is what kind of a line? Solid, we can get away with it. Now if that line had been dotted, then you would have said no to this. Okay. All right, guys. Questions on the notes at all today? Feel pretty good about it? This goes pretty quickly. I'm going to send the assignment out. I want to make sure you guys get this. It is Thanksgiving time, so I do need to give you an assignment. I wouldn't feel right if I didn't.